All right, so now let's use the factor theorem, which pretty much is going to sound like the same thing I've been saying, because I like previewed what all of this means. All right, so the factor theorem says if the remainder is 0, or if you substitute it and you get 0, then this piece, let me highlight this piece right here, is a factor. And that's what I've been saying. So let's do some more problems and let me show you. All right, so first I want to divide by synthetic division. And I want to show you the relationship between synthetic division and the factor theorem. All right, so synthetic division says take this guy, 3, and I know we've done this problem. Or maybe not this particular problem. We did a 21 one. And then set it equal to 0. And so then we get x equals -3. So I'm going to do -3 here. And then I'm going to do the coefficients of those guys. I'm going to do 1, 1, -6. Bring it down and multiply. -3, add -2. -3 times -2 is +6, so we get 0. And now I'm going to go down 1. So I get x minus 2. So this guy right here is my remainder. And so because my remainder is 0, then he is a factor. And he is a 0. All right, so we use synthetic division to show this, okay? Or I can use the factor theorem to check if x plus 3 is a factor. And so what I do is I take the x plus 3 and I set it equal to 0, so I still get x equals -3. And so I'm going to do -3 squared plus -3 minus 6. And so I get 9 minus 3 minus 6, which is 0. And so because I get 0 right here, that 0 right there is equal to this 0 because it's the remainders. Then x minus 3 is a 0 and x plus 3 is a factor. So the factor theorem says if it's a factor or not. The remainder theorem says what the remainder is. And then there's going to be another one that says, is this a 0? Is this a root? Because remember, root, 0, x-intercept, and solution, those all mean the same thing. Let's do another one. Use the factor theorem to determine if x plus 1 is a factor. All right, so we're going to solve this guy. Plus 1 equals 0. And so we get -1. So I'm going to do 2, -1 cubed plus -1 squared plus 2. 2, -1 cubed plus -1 squared plus 2. Okay, and I typed it in my calculator. I got 1. So the remainder is 1. So that means that x plus 1 is not a factor. And that means that we'll learn later that x equals -1 is not 0 because the remainder was not 0. Right? Use the factor to determine if x minus 1 is a factor of that polynomial. Alright, so I'm going to take this guy and do x minus 1 0. And so I get x equals 1. I'm going to add 1 to both sides. So I'm going to do 1 cubed is 2 to the 1 squared is 3. I get 1 plus 2 minus 3, so I get 0. And so that is my remainder. And since my remainder is 0, then x plus 1 is a factor. That's what the factor theorem says. And then we're going to learn later about a different theorem that says x equals 1 is a 0. Right, so we're going to identify the zeros of this, and the zeros, the same thing as the x-intercepts. They're also called the roots. so called the solutions. So that is at -6, -4, and -1. Right, so those are the zeros. I want us to also practice, if we have a 0, how we write that factor. And so that would be x plus 6. This one right here would be x plus 4. And that one right there would be x plus 1. And then if we wanted to know that equation, we would multiply all this out. I'm not going to do that, but we could multiply it all out. So these are the zeros right here, these guys. And then these guys right there, just so you know, are the factors. All right, so that's the factor theorem. And it's still tying everything together so that we can learn more about a polynomial function.